In this video, we consider two jointly normally distributed random variable, and then we divide them, and we want to find the distribution of the division. And in this example, this is a very interesting example which shows that the division sometimes it could be dangerous. So consider that you have two random variables x and y. For simplicity here, I assume that they have zero mean and different variances and correlation coefficient. And we want to find, we define z equal to the division of the two, x divided by y, and we want to find f z of z. Obviously, here they are not necessarily independent. We are also interested to see. So, so if I use the general expression we obtained in the previous slide, and then if I substitute this integral, I take the constant value out, which becomes this one, and then you have absolute value of x here, and then you have this function there. So how to calculate this integral? You could see that you replace y by xz, so this will become x times z, and this y become x times z. So you can take a factor of x2 out, and then you get this function. So somehow you could manage to calculate this integral, and you will find this expression. The result simplifies. This is and this distribution is called Cauchy distribution. This distribution has interesting properties because you say that this is a function of, let's say, centered at this point, okay, and the width is proportional with sigma x divided by sigma y times this one. But even though the center of this function is this value, expected value of z, which is equal to integral of z f z of z dz, z from a minus infinity to plus infinity, this integral diverges. That means that it will not tend to any fixed value. It could be any arbitrary number diverges. That means that in practice, if you draw samples from this distribution and if you average them, the sum of the average, when you add them together, if you take 5 of them divided by 5, it is not guaranteed that it will converge to this one. As a matter of fact, it does not converge. So the mean does not converge. The mean does not exist. Not exist. Moreover, the variance sigma 2 of z is not equal to that and is equal to plus infinity. So it means that if you calculate this variance from the data sample, it becomes infinity as you increase the number of samples. Usually it is rare. So this means that when you divide x by y, the result of the division sometimes is a very large. So if you plot the PDF, the log of the PDF, if you, instead of these, if you plot the y-axis in a log domain, if you plot ln of f z of z, you will find a distribution like that. And the tail means here, this area when z goes to minus infinity or plus infinity are very large. So this is why it is not convergent. For instance, for a Gaussian distribution, this function still, when the log becomes minus infinity, which is in a linear scale 0.